6. I think Monday's class I was trying to record it and it didn't record for some reason. So I'm going.
Yes, sir. Only saw a little part of it on Facebook.
Yeah, I don't know what happened. Thought it was doing recording well, and then when I checked, nothing. So just take it down. All right. So I think we're good here. This is streaming. So I using YouTube instead because YouTube more reliable with the recording. All right. All right. Let's go. Yeah. So that's good. All right, guys. So now, so remember this is ORR. What's happening here? Okay, this is a ORR, and certainly an AI. All right. Now going through this, when I assume that we have everything here set up, I'm trying to see if we use there or anything we didn't add in the apparatus. But I want to get this part correct. Apparatus, test tube, drop a pipette, and labels. Okay, labels were on those already. All right. We didn't probably. I don't think we use a marker. So let's remove that. All right. Lead acetate, silver nitrate, sulfuric acid, sodium chloride. We use those. All right. Diagram not major at this point. You usually would have a label diagram. So the key thing here, when you're writing your labs, I think the moderators look at these things. If you have diagrams, you label it. So bear that in mind. This wasn't labeled for some reason. So I'm just going to finish this. All right, test tube there. All right. Method now, we went through the method. I think we reached up to about was it 5? Yeah, and ammonium hydroxide was one of the reagents. Did we put that up here? No, ammonium hydroxide. And point out here that when I think I made an error where said when you add the sulfuric acid to the salt, we got chlorine, but it's not chlorine, it's actually hydrogen chloride. And then the hydrogen chloride reacts with the ammonium hydroxide to give us the white fumes. So we're gonna go through that today, and so that you can do the analysis part of the lab here. All right, as a matter of fact, observation, I will probably put these in red so that we can distinguish them, so that you don't write them up when you're writing your lab. So anything you see in red here, that it's not going to be written in the method. So I'm going to color these. All right, anything results would be in red here. All right, white precipitate formed. Of course, when you add the this is it's going to be what the silver nitrate. So key thing here is that you're getting marks for the analysis part of this lab. You're getting marks for the correct formulas here. Correct formulas for each of these things that we have here in Word. So ammonium chloride should be written in terms of the formula. Silver nitrate, the same thing. Hydrogen chloride, all those things need the formulas need to be correct for those guys. And we didn't do number 5. The confirmatory test number 2 was to write the reaction here between salt solution and lead acetate. Lead acetate, I think I introduced this to some rules here in terms of solubility. So let me just confirm those. Solubility. I think we could focus on that today. Solubility of salts, not salts, but of compounds. And why it's important to know this is that it will tell us when we're writing equations, we're supposed to write the state that the substances are in. So that will the solubility now will actually tell us like for example whether it's aqueous or whether it's solid or liquid. So all of those things are gas. All right, so solubility of compounds from this experiment, the lesson is that all chloride, right, all compounds having chloride or ending in chloride, ending with the word chloride. So all chlorides are soluble. So soluble in water. And in reactions, we write that as aqueous, except for lead. All right, lead chloride. All right, and that's PbCl2. And also except for silver. So silver chloride. These are the only chlorides not soluble in water. All right. So it's AgCl, that's the formula for silver chloride. And going back, also I think mercury chloride also is not soluble. So let's put mercury here. Mercury chloride. And this is just at CXE level. So there are other exceptions here, but then at CXE level, these are the ones that they expect you to know. All right, HgCl2, I think mercury chloride is divalent there. All right. So any questions here, guys?
No, sir.
All right. Just confirm that. So all chlorides, let me even see if I can highlight this. All chlorides are soluble in water. And soluble means that it's going to be in aqueous. So let's put this in a different color to separate it from the exception. So it's going to put this in black here. All right, so all chlorides are soluble in water except, all right, probably this should be in caps too. So big and bold here, except for lead chloride and silver chloride and mercury chloride. These three are not soluble in water. So when you're doing this, when you're doing the analysis, it needs to show up in the and it needs to show up in the equation. So I'm going to show that in a minute. All right. So that's the takeaway lesson here, guys. All chlorides are soluble in water except these three. And that's why we use silver nitrate, because when you add silver nitrate to to sodium chloride, we end up with silver chloride and sodium nitrate. All right. And of course, that's how chemical reactions work. Let's show how that works out in a minute. All right. So now, all of what you say, I put in red here in the method, guys, that should go into the observation. Let us citate here. This also should go in the observation. All right. Of course, lead chloride, the result here. By the way, let me change this and this result here. It's actually, this part will go in the analysis. So I might need to even change this color too, because you see, observation is all about color change, guys. I don't know, let me put the result here, but I'm going to change it. It's going to be analysis. I'm going to put this in blue or something, because yeah, put all of the analysis in blue, all the observations in red. All right. And that could be in blue as well. All right. So let's try and organize this lab here. All right. Yeah, analysis definitely it's going to be in blue. So I put that in blue there, guys, and just make the lab more easier to read here for you guys. This should be in blue. Let's go up to top here. Solvent water, white fumes, the shape of colorless crystals. Those are okay. All right. So, all right, guys. So I hope you understand what's happening here. Anything in blue is the analysis. Anything to do with analysis here. That goes into the analysis, right? Explanations and reactions for things taking place here. All right, let me just put that in there. Man, what's happening here, man? All right, so there you go. So that's cool. Um, yeah, appearance of salt, you can fill those in. Certainly, this now, and here we have the test here. All right, so the test is basically the method, the observation is what you see, inference here. I'll just color this part in blue so we can maintain the color code here. All right, not copying, not selecting at all. All right, I'm just put that blue. Put that in blue, keep it there. All right, so there you go. All right, guys, let's look at the first test. Probably I can just make this a shortcut here and just copy and paste or something. Let me try that. Method. All right.
Sir, should I do this lab as well?
If you realize, Kimberly, you did this lab. This is the same lab that you did on Tuesday. Wait, which is today? No, yesterday. You did this lab yesterday.
Oh, okay, sir.
All right. All right. So I think the observation here, salt is in the shape of crystals. No. So this is the first test, guys. So please small amount of salt. All right. When you copy this and put it right here, so guys, in the method. So it's for everybody doing lab. Let's put that there. All right, good. So we have this, guys, and yeah. Put that there. Oh, all right. That's this fine then. To that thing. That right there. All right, observation. Can drop that in there. So I just showing you how it's supposed to set up in this table. So Odell did a good job at this. So the others who maybe never do it before, that's usually how you write it up in the table form. All right. Now, so same thing. I'm just actually taking out the methods and putting them on the left column. All right. And then now come over here. So now I'm dropping that right down to 10 and put it here. Of course, I probably could
But sir, are we still supposed to write out the method as in previous labs?
You know, say if you do it this way, you mean like how it stay here?
Not table format. Just write it out. As in when we normally write method in other labs.
Yeah. So then
not table format.
All right. So let me see how that would look now. You'd have a results in. Yeah, write out the method. Write out the method because this method now not gonna have anything after a while, no. Because when I take out everything that's in red here, and everything in red and everything in blue, you're going to realize say everything I go short. Yeah. So I'm trying to set it in the table format now, so you see how it look like. Persons in the waiting room. Who are these persons? Michaela and Deborah. All right. So yeah. Hold on a sec. Let me see if there's a way you can get around not writing the method here. All right. You know what you could do? All right. It's when you reach method, you can just write C test.
Oh,
Yeah.
okay.
So yeah, that's right. C the test. Yeah, I can write that. Make it shorter. So
But nothing would be wrong if you write it out.
no,
Okay, because I wrote it out already.
nothing is wrong if you write it out. I'm just trying to minimize the work, but yeah, if you write it out already, fine. No problem. Yeah. All right. So there you go, guys. And once we do this now, we're going. That's basically the whole. All right. You see, after this now, after we do this lab now, we have the same thing to do for testing for bromide ions and for iodide ions. All right. So when you say how this right up now, I can go ahead and do the other experiment now, which should carry to lab 7. In Kimberly's case, it will be lab 8. And then you do the same similar right up here. And then following after that lab now is a test for cations. And that will take care of all of the qualitative analysis that you would need to know. There is also one where you should test for gases as well, but then that's more of a face-to-face thing. So based on how things going, not like that we'll get to do that. But certainly we want to do at least 2 qualitative analysis labs because that's compulsory. All right. So and in case you didn't know, well, CXE looks at when they're gonna give you the grade for your SBA, which is 20% of your exam grade. They look at the labs that you do. If you don't cover all of the topics, they're gonna mark down your SBA. So you realize that it's not so much about the amount of labs that you do, but it's pretty much which labs you do. So that's what we're doing now, focusing on certain labs. So that's why I reached this far, and then we're going to follow that trend. All right. So hope everybody's seen how it should be written up though. We just using the method to describe the test that we did. And that's what we're doing here. I'm pasting this one. Again, lower the font size and 1 to 10. And just drag it here. And then of course we can just pull this in. All right, so there you go. So that's how it will look. Let me save this as in case anything should happen. And this is the of course the IPAS version here, and today is the what 14. All right, there you go, guys. All right, so then that is out of the way. So I think it's what 4 tests or 5. One of the 3 already. So 4 and then 5. Dropping them down here. I mean fast. All right, drop it down to 10. Carry it down. Scrolling. Oh, Grace. Interesting. Wasn't thinking that Grace would be here. But here's Grace. All right. And then number 4. That's a silver nitrate. We just copy 4 a while ago. So this is 5. All right. Copy that. All right. So table format, guys. That's how we do qualitative analysis for CXC. Put this at 10. Drop it. And drop this in here. All right. So there you go, guys. So this is a method in a condensed form. Observation now, just like we do the method a while ago. Just going to follow the same thing. All right. So like for example, this now I'll copy that, put it here. Yeah, and that's it. Now you could even put it in your own words. You could say, well, salt dissolves in water. Whichever way you want to write it down, just make sure so you have something in there so you can get the mark for it. All right. So first one, soluble in water. This one, no observation, dense white fumes evolve. All right, let's copy that, put that in the table. And I can remove the observations because the observations are already at the top. And that is what it would look like. All right. And the third one now would have the same. All right. Oh, this analysis here. This is the first one with analysis. This is the analysis for the first one. All right, so guys, let me show you how we do this one now. Copy here. And we'll go for the inference now. That's where you have the analysis here. Color changes. All right. This is where we're going to put that. We might need some space here. Put that in blue. Carry this down to 10. Should be able to hold here. And move it up here. And drag this in. All right, there you go. This is our thing now, guys. All right, so I hope you're seeing what's happening here. It's gonna be in red. That doesn't matter really. Just drag this in somewhere. That in red. All right, there you go. All right, guys. So see, that's how it's supposed to look. All right, now. All right, everybody understand this?
Yes,
sir. I was doing it also, sir. Only thing I didn't do the test and the inference, but I write in all the observations.
All right. Yeah, well, let's get the inference there. All right, let me see something here. Was this the correct one? No, I think this one's supposed to be here. You're not gonna have no inference with this one. Well, you could make one. In fact, let me change the color to blue here and show you something. If I were writing an inference here, although this would be just so you'd write something like this. NaCl is solid, so you put S there, plus H2O. All right, and then of course this will go to form NaCl aqueous. So you write something like that. All right. In this case, sodium doesn't react with the water, it just dissolves. When a microscopic level, it's a small reaction, but not where new products are formed here. At least the only products you're going to have here are some ions, really, which you get the hydroxide ion and the hydrogen ion when this happens. But I mean, this is a reaction, right? So that's the inference. So maybe a 1 mark for showing this, just to get into the practice of writing equations. Also, inference is all about writing equations too, so bear that in mind. So I'm actually going to increase or improve this, what we have here. Colorless hydrogen gas evolves, which reacts with the, all right. So this now, guys, will have 2 parts. All right. Colorless hydrogen chloride gas evolves, which reacts with the ammonium hydroxide. All right. So, guys, this is it now. This is going to have 2 equations here. All right. This evolves. Anything will evolve is a product. But then if we go back to the test, what happened here, put a small amount of salt in the test tube, all right, using the spatula, then add drops of concentrated sulfuric acid. This part, we need to write what happens in this part, guys. So what really happened here is that we had the salt, NaCl. This was in solid form because we didn't add any water to this, right? The test was that we take a small amount of salt, put it in the test tube, and then now we add drops of sulfuric acid, which is H2SO4. All right, let's see if we can get a zoom on this so we can see exactly what is happening. All right, so it's gonna be H2SO4, guys. Let me just write the correct formula for sulfuric acid. And this arrow shows that it's going to form something. No, before you even put this arrow here, the sulfuric acid was in liquid form. You know, acids are always liquids, really. So aqueous is the state symbol there for the acid. But these two reacted, and for some, well, and the reaction is that the sodium, well, you're going to get what? Sodium sulfate. And as I tell you, in reactions, this is what you call it's like a substitution reaction. It's actually a double substitution. So sodium comes over here and hydrogen comes over here. All right. And so you're going to end up with this HCl. This is the gas that come off. And plus the sodium will come where the sulfate or beside the sulfate, replacing the hydrogen. So it will be Na. It's going to be Na, running out of space here, it looks like. It's going to be NaSO4, actually Na2SO4, and some balancing needs to take place here. So, and balance this equation afterwards, though. But, yeah, just trying to get this arrow alone to move so I get some space. But, all right, there you go. All right, so that happens. And we delete that one. All right, guys. So, any questions here?
No, sir.
All right. All right. So that's the first equation. Now, the second part. Now, let's go back to the test again. So all right. So concentrated sulfuric acid, then moisten glass rod with ammonium hydroxide. All right. Then hold it at the test tube's nozzle. All right. So then here's what's going to happen. The hydrogen chloride comes off. You said dense white fume evolves. All right. This happens when we bring the ammonium hydroxide at the nozzle. So the HCl, as you can see from the first equation, is a gas. So this will come up this will be what? Na2SO4, actually it's aqueous. Anything that has sodium in there is soluble, guys. That's another rule. Any sodium compound is soluble, except when otherwise stated, really. But in this case, it started out being solid, but because the acid has water in it, then it will dissolve. The sodium will dissolve in it in the form of sodium sulfate here. All right, so the HCl gas will come off. That will go to the top of the nozzle. HCl is that fission reaction that takes place, and the HCl is a gas which will meet up with ammonium hydroxide. Ammonium hydroxide is actually a liquid, but it gives off ammonia gas. So it's the formula there would be Na3. All right, it'll be Na3. Sorry, NH3. This would be a gas, and then we get this forming NH4Cl, and this is actually a gas. Well, it doesn't become solid because of the temperature still, but actually going to be a gas there. All right, so dense white fumes evolve. That is actually, this is the reason for the dense white fume, guys. All right, this is a white gas. Sometimes it sublimes if the temperature is cool, it sublimes into a solid. All right, so that's it. All right, so that is how you'd get marks here for the inference, guys. All right, so this is where I wanted to help you with, so that you see where this lab is important. All right, I'm going to show you this now in a version where CXC asks a question. In fact, if I should go and find a past paper question, usually they send this in the first question, and that was like before like 2016. I think they changed now. They start to put the qualitative analysis in different parts of other questions. So you might be doing a question about bonding, and all of a sudden the last part asks you describe a test for, you know, chloride ions just out of the blue there. So they're throwing it in questions now, but usually it was a question by itself. All right. So that's why this lab is important for us to do. All right. All right. So any questions here, guys? 1, 2, 3. I guess 4 marks here. All right. So this looks like about 4 marks so far from the analysis based on the mark scheme. I would have to go back to that mark scheme and see what happens there. All right. So do that qualitative analysis thing here. All right. All right. So place a small amount of salt in the test tube. Now we're looking at the third test. Oh, hold on a sec. What happened here? So we put the same thing twice. All right, no problem. Just can just move up the other one. No problem there. All right, so we'll copy the put this twice, so this can move up. It'll be easier then. All right, this have a small amount of the salt in the water, then add drops of silver nitrate to it. All right, this can move up as well. This one is the lead acetate here. All right, these also have equations, guys. Important equations. This one very important though. All right, CXC again, testing for halides or halogens is silver nitrate is the most important, most common test for that. So add silver chloride to anything that has a chloride or a bromide or a iodide, and there will be a color change. There will be a precipitate. So let's look at this one. All right, silver nitrate is key here, guys. So what happened in this experiment? If you had the results for this one, let's go back to this one here. It says a white precipitate was formed. First confirmatory test here. So let's put that in the observation right here. White precipitate formed. All right. No. Let's go one further now. What is this white precipitate? We have to show how it formed. All right. No. So this is actually pretty simple. All right. Is there any analysis that we need to copy in here? Let's check. All right, analysis here. All right, so this is analysis. Let's copy this one, guys, and go put this in the inference. Put that right here. All right, change the font size here, so now make it can hold. All right, data 10, and we have blue, and we'll just drag this in some more. All right, formation of white precipitate of silver chloride, which is soluble in ammonium hydroxide. All right, it's cool, it's cool. Do I need to put this though, because them never say nothing about ammonium hydroxide here, so no, we can't take out this part, no. No, just stop it right there. That makes, yeah, can just leave it right there. All right. Formation of white precipitate silver chloride. So this now just going to explain what caused the white precipitate. So again, we start out with the salt NaCl. This was a small amount of salt in water. So this was aqueous. This salt was dissolved in water this time. Added silver nitrate, formalized AgNO3. All right, this silver nitrate was in aqueous form, guys. So we need to make note of that state symbol. Can't overstate that. Need the state symbols here. All right, these are two aqueous things. We'll probably run out of space here, so let's finish it down here. Or we can get space. Let's zoom in and see what happens. Yeah, we definitely need some more space there. All right. So, all right, NaCl. Let's see what's going to happen. Same reaction here. The sodium part will be exchanged with the silver part. All right. Now, some students do some silly, annoying things like switching the sodium with the nitrate or putting the chlorine where sodium should be. Just remember that the front part of the compound, it's black off here, can only replace the front part of another compound. All right, so that's it. All right, so that is it. So as you see in here, this is what double substitution, guys, right? So what it is now is that sodium will replace silver and silver will replace sodium. All right, that's a double substitution reaction. All right, so what's going to happen here? Silver chloride will be formed, which would be AgCl. This will be solid. This can dissolve in water. However, the instruction or the information was saying that this, although it can dissolve in water, can actually dissolve in ammonia, but that's not our concern. Silver chloride will not dissolve in water, period. Regardless of what other thing it can dissolve in. And then, of course, let's see what we have here. The sodium will be over here where the silver was. So there's a substitution there. It's actually going to be NaNO3 this time around. And this will be in aqueous. Again, that's the other rule that we need to remember, guys. So we're coming down here. Where did we write that rule before? It's right here. So all nitrates are soluble. So let's write that down. So you guys always remember that. All nitrates are soluble in water. There are no exceptions. This is just it. All nitrates are soluble in water. All nitrates are aqueous. All right. End of discussion. Doesn't matter what come before the nitrate. Could even be silver nitrate, could be lead nitrate, mercury nitrate, if that exists. Don't have that compound, but if it did exist, anything with a nitrate, anything ending with a nitrate is soluble. All right, which means that when you're writing it in an equation form, we're going to have to put aqueous beside it, just like we're doing in this experiment here. All right, so it's aqueous. Any questions here, guys?
No, sir.
All right. So either you understand or you're not there. So let's move on. Let's continue. This one now is the lead acetate now. And then, of course, this is a white precipitate. Let's go back to the results that you should have. White precipitate formed here, guys, with the lead acetate. So when I have to write the formula for lead acetate and show how with this white precipitate forms. All right, so let's go back here. And we can just copy this. This is easy stuff to do here. Just drag it down. Same white precipitate, but this time different reaction. So I have to make a note of that here. Let's get or let's copy the analysis. All right. There you go. And we're copying this, guys. All right, it's putting it right here. All right. And it decides to be up here, but we're going to fix that now. Let's drag this. All right, so we probably can small up the font as well. So this would be like a size 10. All right, I'm good here. All right, so there we have that, guys. White precipitate lead chloride. We need to show how that form. So, all right, so first of all, let's say the test was to dissolve a small amount of salt in water in a test tube. All right, so let's get that test tube with this salt. So it's gonna be what? NaCl. Let's change the color. Let's stay consistent with the blue here. So it's gonna be NaCl aqueous. All right, definitely adding some lead acetate to it. Now, this formula can be written two ways. I think I want to write it this way though, for consistency. PB, and it's going to be C2, and acetate would be C2 at H4O2, if I believe. No, it's actually H3. Let's confirm that. And the other way we could write this compound is lead acetate would be, write it somewhere else. It's going to be P. All right. In some books they will write it this way: CH3COO bracketed 2 and PB. So if we count up that, we're going to end up with what? 2 C's. How much H? A 3 then. All right, so H3O2. All right, no problem there. But then that's actually 2, so we have to bracket this and put 2 there. All right, so this compound can be written 2 ways though. Let's take off this one. All right, so anyway, not important. I write it for you so you don't have to worry about how this works out. Acetate ion is just a combination of carbon, hydrogen, and oxygen to form a single ion. And this ion is found in vinegar. Hence, it's also called acetic acid. But then this is a salt that is formed from vinegar. So it's C2H3O2 acetate ion there. All right, so then that is happening. We don't need to concern ourselves about that. What's going to happen here? Same thing, double substitution. Sodium replaces lead replaces sodium. Switching places there gives us PbCl2. Pb, which is lead, give up 2 electrons, so hence the 2 in the bracket here. So when it comes over beside chlorine, so don't give up 2 electrons as well. So that's why we keep PbCl2 there. Because of the lead, that's how it behaves. All right, then sodium now only give up 1 electron, so therefore it doesn't change the formula. It's going to be sodium acetate, which is NaC2H3O2, and this is soluble, so let's put aqueous there. This part, anything with acetate is aqueous as well, so all acetates are soluble. So let's go with that. All right, so it's notice lead chloride is actually solid. This is what you call precipitate, guys. This is a precipitate. All right, that's the precipitate. This is the precipitate. And that's what you have. All right, so this is it. We're done, you know, guys. This is it. Lab done. Most of the marks you'll get here. All right. Any questions at this point?
No, sir.
All right. So, all right. So so see this. So we can clean up that. We can clean up here, so you know. Can't forget about this. We have everything. Let me save it to just in case somehow. All right. And then take all that part little. Let's fix it up. All right, and then this can come out. All right, and then this can come out. So notice the method is a lot scanty now, a lot more scanty, which is easier to write up. This can come out as well because we already have it in the table. All right, that's number 4 confirmatory test. This can come out as well, and this can be removed. And that's it. Lead chloride, explained that already. So, and of course, number 6 and 7 say perform appropriate steps for identifying bromide and iodide. Record the results in a suitable table. So when we change, when we go up here, so now and we do the lab, whichever number it is, we're going to change the chloride ions to bromide and iodide for the next time. And we're going to do a similar table like I'll show you today. All right, so look out for that one. All right. No, write explanations for reactions taking place. Again, I could just simply write C. Yeah, just write C table. And because everything is there, we don't have to go back and write this again. I mean, I put it this way because this lab could be written up in 2 ways, in 2 formats, but the most popular format for any qualitative analysis lab is the table format like this. So once you do it this way, then you don't have to worry yourself about the regular way for the other labs. All right. Again, we gave you some source of error, so you know, we mentioned the visual errors here. In color of precipitate. Of course, the precautions here. I remember. Did I give you any precautions? Who was at the lab last class?
Yes, sir, you gave us precautions.
Mm-hmm.
Ensure the apparatus is clean before use
Okay,
to
good. So,
avoid contamination.
all right, very good. You can add that then. All right. So that's clear. All right. So use of clean, sterilized apparatus. Yeah. All right. Conclusion now. Your conclusion will be what from this experiment? You know, the chloride were identified. Mm. The sodium. The sodium chloride sample. Yeah, that's something like that. Usually I get 2 marks for the conclusion anyway. And then your reflection is where you learn from the lab. So I don't know. But this is just notes though. What you're seeing here, this is just notes. Important notes here. All right, so important notes. This here. I just drag that over. All right, so all of these important notes, as we go along, we just highlight them from the lab. All right, so that's it. You know, I mean, you just went well in terms of observation, it's already there. So in the column there, but that's it. That's it. Not a very it's not a difficult lab, but it's a lab where you have to learn a lot. You have to know a lot of things, right? It's not gonna be that long. All right. Now, let's see if at this time now we can find the question set the CXC, because that one now, and I just wanted to have a good look at it before, because I want to show you why I'm going so hard with this. All right, so let's look at the past papers up to, yeah, I think we have something there. Yeah, so hopefully this will be opening only. All right, let's see, pick up where we left off. Oh, this was the last thing we looked at on the paper here. All right, and I'm just going to randomly go through here. These questions here. Whoa, hold on a sec. I think I saw something. Whoa. Yep. I've seen one here, guys. This was 2013. All right. Look at this, guys. Everybody seeing this?
Yes, sir.
Yes, sir.
All right. Question D of the first question from 2013. Table 2 shows the test performed on a substance labeled Q and observations of the test. Complete the table by inserting the appropriate inferences. All right. No, small amount of solid Q was placed in a test tube and heated over a Bunsen burner. All right. They didn't tell you anything about the color. Just say it's solid, and they put over a Bunsen burner heat there. All right. Observation: brown gas evolve. All right. Here's a little trick here, guys. Whenever I see a brown gas evolve, brown gas and CXC chemistry can mean one of two gases. All right, brown gas could either be either nitrogen dioxide. Notice I didn't say nitrogen only, no, I said nitrogen dioxide, so it's nitrogen dioxide. That's nitrogen combining with 2 oxygens. And or it could be bromine. All right, so these two are the common red-brown gas in chemistry at CXC level. All right, everybody get that? Everybody heard that?
Yes, sir.
Yes, sir.
Yes, sir.
All right, now, how can we know which gas it is between bromine and nitrogen dioxide? If both of them brown, how can we know which one? The next observation is that damp, all right, so damp blue litmus paper changes to red. Now, any paper you use to test for gas that changes from blue to red is telling you that the gas is acidic. So there's an acid there. Now, between these two, nitrogen dioxide and bromine, nitrogen dioxide is acidic. So litmus paper is used to test for acids. So it's actually tests acid or base. Well, no, those test acids really. So because them say blue, and then say blue litmus test for acids. Red litmus test for base. Blue litmus test for acids. So let me just say, all right, blue litmus is used to test for acids. All right, so blue litmus test for acid. Change it to red. Which one of these is acidic? We said between nitrogen dioxide or bromine. All right, taking too long to answer. So make up your mind. It's actually going to be nitrogen dioxide. Brown gas evolve, it could be NO2 or BR. All right, but see that?
Yes, sir.
Yes, sir.
All right. Solution of potassium iodide was added to a solution Q. So same Q here. So what we're seeing here is that in the first part, Q is found to have nitrogen dioxide. Because and this is a trick here. This is actually telling you two things, because any compound that is nitrate in its solid form, 9 out of 10 times when you put it over a flame, it's going to decompose. And when it decomposes now, any nitrate that decomposes usually goes to form nitrogen dioxide gas. And that's one of the ways they can make nitric acid in the lab. But anyway, let's continue here. Solution of potassium iodide is added to a solution of Q. Bright yellow precipitate form. This is, well, I would say it's a giveaway, but bright yellow precipitate, the only one you will find like this in CXC, bright yellow precipitate, is actually it's gonna be lead iodide. So at this, yeah. So there are some little tricks in CXC, guys, that when them use these terms, you just know the answer. That's why, in my opinion, CXC is an easy exam based on how we set the question, just giving you the answer right away. Potassium, well, this is actually lead iodide. All right, so what they also have ionic equation. So all right, bright yellow precipitate form. All right, so we could write lead ions present. We could also write Pb2 plus really. That's the formula for lead 2. So let's put lead 2 just in case. Well, this video is on YouTube. People might comment and say, well, sir didn't say lead 2, but it's actually lead 2 there. Because there's lead 4. And remember, CXC don't really ask about lead 4. This lead 2. That lead 2 forms a yellow precipitate whenever it reacts with something with iodine, or in this case, potassium iodide. All right, so now balance ionic equation. They said they probably want the full equation. So all right, basically just like I showed you, it's because I know that lead is there. It will be actually Pb. And I'm gonna have to show you how to write ionic equation next time, because it's actually class is actually over. But I'll show you how to do this next time or some other time. PbNO3 though is lead nitrate that actually reacts with Ki. Same double substitution thing take place. Lead or rather potassium will take the place of lead. Remember, potassium is more reactive than lead, so potassium will remove lead, and we're going to end up with KNO3. All right, so this is the reactants. They're reacting. Lead replaces lead. Lead replaces potassium. So you're going to have PbI2. Remember, anything with nitrate is aqueous, sky with dissolving water. PbI is solid. All right. This is not entirely complete though. So I'll finish this next time. I only want the ionic equation, so I'll show you that next time, guys. All right. So any questions about this, guys? Remember?
No, sir.
All right. There are dozens of questions and CXE past papers with this. So once you work through all of them, you're gonna basically know any test them can throw at you there. And that will give you certain marks in the exam. All right, guys. But thanks for coming out today, guys. And